Okay, now we'll start with the next type, which is called as the exponential part 2. Now what is different here? Here you will be using, again we are doing exponential part 2. Now let's see this. The formula that you will use here is limit of x tends to 0, 1 plus x raised to 1 upon x is equal to e. Okay, now let's see this. First sum, we keep this separately here so that we know what formula we are using. Limit of x tends to 0, 1 minus 4x raised to 3 upon x. Now let's see how do we do this sum. This can be written as limit of x tends to 0, 1 minus 4x can be written as plus into minus 4x. Now the formula says that whatever is the number here, the same number has to be there in the denominator of the indice. So since I have minus 4x here, I'm going to write this as 1 upon minus 4x, but I already had an indice. Since I've divided the indice by minus 4x, I'll multiply by minus 4x, and whatever indice I had, I'll leave that here as it is. Now this bracket is going to give you e. 1 plus x raised to 1 upon x is e. X and x gets cancelled, raised to minus 12, 4 3s are 12, sum is over. Fine. Let's see the next sum, guys. Limit of x tends to 0, 1 plus 2x upon 1 minus 3x, the whole thing raised to 1 upon x, right? Now let's see how do we do this. This can be written as limit of x tends to 0, 1 plus, I'm going to use the law of indices, a upon b, the whole raised to m is a raised to m upon b raised to m. So this can be written as 1 plus 2x, the whole raised to 1 upon x, upon 1 minus 3x, the whole raised to 1 upon x. Now this can be written as limit of x tends to 0, 1 plus 2x, whatever is the number after 1, same number has to be there in the denominator of the indice. Since I am multiplying the denominator of the indice by 2x, to keep the equation constant, I will multiply the numerator also by 2x into 1 upon x. Same logic here in the denominator. 1 minus 3x. That means whatever is the number here, same number in the denominator of the indice. Right? Whatever is the number here, same number in the denominator of the indice. With the minus sign I am taking it. Since I have multiplied the denominator by minus 3x, I have to multiply the numerator also by minus 3x into 1 upon x. This bracket is going to be equal to e, x and x gets cancelled, e square upon e raised to minus 3, laws of indices, e raised to 2 plus 3, e raised to 5. Right? Let's move on to the next sum, guys. Limit of x tends to 0, 3 plus 2x upon 3 minus x, the whole raised to 1 upon x. Right? Let's see this sum. Now the problem is my formula says that the first term should be 1. Here the first term is 3. How do I convert this into 1? For that I will divide numerator and denominator by 3. If I divide numerator and denominator by 3, I will get limit of x tends to 0, 3 upon 3, that's 1, plus 2x upon 3. I have divided both the terms of the numerator by 3. Similarly, I will divide both the terms of the denominator by 3 raised to 1 upon x. Now the same thing that we did in the previous sum. Limit of x tends to 0, 1 plus 2x upon 3. Whatever is the number, you need the reciprocal of that in the indice. So I'm going to multiply the indice by 3 by 2x. Since I have multiplied the indice by 3 by 2x, To keep the equation constant, I multiply it by 2x by 3. This 1 upon x as it is. Similarly, in the denominator, this is 1 minus x by 3. Whatever is the number here, same number in the indice in reciprocal format. To keep the equation constant, minus x by 3 and the 1 by x here. The 1 by x goes to both the numerator and the denominator. Sums done. So this is going to be e, this square bracket, raised to 2 by 3, and this is going to be equal to e raised to minus 1 by 3. So this is e raised to 2 by 3 plus 1 by 3, 3 by 3, answer is e. Fine. Let's move on to the next sum, guys. Limit of x tends to 0, log 10 plus log x plus 1 upon 10 upon x. Let's see this. How do we do this? Now, this can be written as limit of x tends to 0, log a plus log b is log a into b upon x, limit of x tends to 0. This x can be written as 1 upon x separately. Now this is log, open the bracket, this is 10x plus 1, right? Because 10 into 1 upon 10 will give you 1. This is limit of x tends to 0, log 1 plus 10x. Whatever is the number before log goes up in the indice. Now whatever is the number here, I need the reciprocal of that in the indice. Limit of x tends to 0, log 1 plus 10x. So in the indice I will have 1 upon 10x. Since I have multiplied the denominator of the indice by 10x, I have to multiply the numerator of the indice by 10x to keep the equation constant. 1 upon x, log as it is, 1 plus x raised to 1 upon x is e raised to 10. This is 10 log e. The number in the indice goes before log, 10 log e. You are supposed to know the value of log e by heart. The value of log e is 1. So the answer is going to be 10. Let's move on to the next one, guys. Limit of x tends to 0, log 5 plus x minus log 5 minus x upon x, right? Same sum, same type sum. Let's see how do we do this. This can be written as limit of x tends to 0. This x I am writing separately as 1 upon x. Log a minus log b is nothing but log a upon b. Since this number is not 1, I need to make the number 1. How do I make the number 1? Divide numerator and denominator by 5. If I divide numerator and denominator by 5, limit of x tends to 0, 1 upon x log, this is going to become 1 plus x upon 5, I divided both the terms by 5, upon 1 minus x upon 5, right? Now, this can be written as limit of x tends to 0, log, whatever is the number before log goes up in the indice. So this is going to be 1 plus x upon 5 upon 1 minus x upon 5, the whole raised to 1 upon x. A upon b raised to m is a raised to m upon b raised to m. That means the 1 upon x will go for both the terms. Limit of x tends to 0, log. Now see this. Let's solve them separately. 1 plus x upon 5. Since I have a x upon 5, to solve that I should have 5 upon x in the indice. To use the formula 1 plus x raised to 1 upon x, The number in the index has to be reciprocal of this number. Now since I have written 5 upon x in the index, to keep the equation constant I will have to write x upon 5. This 1 upon x as it is. Similarly, in the denominator, this is going to be 1 minus x upon 5. Right? So in the index I will write 5 upon minus 5 upon x, reciprocal of this number. To keep the equation constant, x upon minus 5 and 1 upon x as it is. Remember I told you this? Okay. Now this is going to be equal to log as it is. This is e raised to 1 by 5 upon e raised to minus 1 by 5. So this is going to be laws of indices. E raised to 1 by 5 plus 1 by 5 log e raised to 2 by 5. Whatever is the number in the index goes before the log. So this is 2 upon 5 log e. But we know that the value of log e is 1. Therefore the answer will be 2 upon 5. Right? Let's move on to the next sum, people. Limit of x tends to e log x minus 1 upon x minus e. Guys, x does not tend to 0. Since it does not tend to 0, the first thing I need to do is I need to make x to be equal to 0. I need to tend x to 0. How do I do that? You will say let x be equal to e plus h. As x tends to e, h tends to 0. This can be written as L is equal to limit of h tends to 0 log x minus 1. This can be written as log x can be written as e plus h minus 1. Since we know log e is 1, I can write 1 as log e. I am substituting the value of 1 as log e upon e plus h minus e. E and e gets cancelled. This is limit of h tends to 0 1 upon h log a minus log b is nothing but log a upon b, right? This is limit of h tends to 0 log, split the numerator 1 plus h upon e upon e is 1, h upon e. Whatever is the number before log goes up in the indice, right? Now this can be written as limit of h tends to 0 log 1 plus h upon e. To solve this I need e upon h. Since I have multiplied the indice by the reciprocal, I have to write the reciprocal outside again into 1 by h, right? So now this is going to be log, this is e raised to 1 by e. This is whatever the number in the indice goes before the log, 1 upon e log e. The value of log e is 1, answer is 1 upon e, right? The last sum to finish this type, limit of x tends to 0 3 raised to x minus 1 the whole square upon 2 raised to x minus 1 sin x log 1 plus x. Now this practically ends up using all the formulas. Let's see how. This is 3 raised to x minus 1 the whole square upon 2 raised to x minus 1 sin x log 1 plus x. I presume this is q. Yes guys, this is going to be q. The sum is q. Okay. Now divide the numerator by x cube. I am dividing the numerator by x cube. divide the denominator by x cube. That means I need 3 x's in the denominator. X, x, x. I have divided the numerator by x cube. I have divided the denominator by x cube. This can be written as limit of x tends to 0, 3 raised to x minus 1 upon x the whole cube upon 2 raised to x minus 1 upon x sin x upon x. Whatever is the number before log goes up in the indice. So this will be log 1 plus x raised to 1 upon x. Start using the formulas, people. So this is going to be log 3 the whole cube, log 2 sin x upon x is 1, log 1 plus x raised to 1 upon x is e, but we know that the value of log e is 1, so the answer is going to be log 3 the whole cube upon log 2. That's your final answer.